Problem 3-34. You decide to park your car in a parking garage that charges $3 for the first hour and $1 for each hour or any part of an hour after that. So ask us some questions here about how much will it cost to park your car for 90 minutes, 118 minutes, 119 minutes, 120 minutes, 121 minutes, and so on. So let's graph the cost in relation to the length of time your car is parked. Is this function continuous? Describe how the graph of this function will change if the parking garage raises their parking rate so that the first hour is now $5. All right, so we're going to start out here. I'm going to graph it first, and then we can look at the actual answers to some of those costs. We're going to start out here. We know that for the first hour, and you'll see my graph down here, I've got hours marked as my x-axis here. That's our independent variable, and our cost is going to depend on the number of hours we're using the parking garage. So it says it charges $3 for the first hour, which means when we're starting here, if we've parked for 0 hours, we would be at 0. So I would want to put an open circle in here. And we're going to get charged $3 though, all the way up until 1 hour. So I'm going to put a closed circle here, and then anything less than that, if we only parked there for 45 minutes, we would still get charged the $3 there. So anything here, anything up to an hour would be charged $3. So then it says it's going to cost another $1 for each hour past that. So once we go over 1 hour, even by a couple seconds or a couple minutes, we're automatically jumping into the next cost range here. So we've got at 1 hour exactly here, we're still paying $3, but I'm using this as a boundary point, and we're going to get charged all the way up till 2 hours. That would give us a total cost of $4. Then if we went, even longer than that, once we cross 2 hours and go above that, we get charged another $1. So we mark our boundary line, and then we're going to go across here. Remember, open circles means does not equal, closed circle means it does equal. Then we continue on there. We'll draw one more in. Let's see, if we stay over 3 hours, we're definitely going to get charged $6. So that'd be an open circle over the 3, and we'd take it to the 4th hour here. Put a closed circle. Now this would probably continue to go on, but I'm going to stop at this point and start answering some of the questions. So how much will it cost to park your car for 90 minutes? That's like 1 1/2 hours. So if we look here at 1 1/2 hours, should be getting charged $4. Second one here says, how much will it cost to park your car for 118 minutes? Well, 118 minutes is less than 2 hours, right? So we would be then looking at $4 as well. So for letter B, 118 minutes would be $4. And for 119 minutes, we're still in the same area here. That's also going to be $4. Then it says, how much will it cost to park your car for 120 minutes? Well, once we hit 120 minutes, we are still getting charged just for 2 hours. We haven't gone over that. So that would also end up being $4. Oops, I put 4 o'clock. I meant $4 there. There we go. Now, 121 minutes, we do go across the line there. So at 100, after 2 hours, we're over 120 minutes. which means 121st minute here, we're getting another dollar charged. So for 121 minutes, we're going to be charged $5. And it says graph the cost in relation to the length of time your car is parked. Well, we've got something there drawn up. It says, is this a continuous function? Well, if it was continuous here, what we're looking at there is there would be no breaks in it here. We actually refer to this as a step function. Kind of looks like steps, right? So no, this is not continuous. It is a step function. And then letter F. Describe how the graph of this function will change if the parking garage raises their parking rate so that the first hour is now $5. So more or less, everything else is going to stay the same. Instead of actually charging just $3 here, it would just move everything up $2. So everything would just increase by 2. So it would shift our graph up by $2. So everything would move up $2. All right, this is problem 3-34. Hopefully this helped you if you had questions. If not, please ask your teacher. Have a good one.